Hi guys, so let us start the next problem in the series. The problem will be word break 2. Okay, so I think it is similar to the word break, but I think vector of string, we need to return vector of string. That means we have to find out the path this time. So given a long string as and a dictionary, all the conditions are same word in the dictionary may be used. Add spaces in as to construct a sentence. Okay, I think yeah, the you are allowed to reuse a dictionary word. So I need to create all the possible sentences that I can make using the above. Okay, so what I will do, so I will just come over here. I will just copy my code from here and then I will try to modify it such that it stores all the instances, right? So basically, let us copy this. Yeah, right. So now instead of just a boolean variable, let us say we are storing a vector of string at each place, right? So we want a variable, so we want our dp to store. So dp of 0 would be an empty string. Yeah. Sorry. Now, what we now need to do is, let us say let us say that this word matches so with this I plus 1 minus alien. So now what I will do, instead of just computing this, I know that what I will do for string I in dp of I minus alien plus 1. So this is because this is a vector of string. So now I have got this string. Now I need to, so actually I need to create a yeah. So all the strings. So what I will do is, in all, first of all, in all the strings, so I need to add a word. So dp of I plus 1 dot. So let us say I what I do is I make I append a space and then I will append. Then what I will do is, I will append the next word, right? So what is the next word? This is this word. Next string. So if I want to add another string, I need to do it in this way. And then the dp of I plus 1 should take note of this string, right? Now, in this way, I have computed all the strings. Now, what I need to do instead, first before returning the vector of strings, so let us say for string, because so if you notice there will be extra spaces in the front because we are first appending the space. So I think instead of first appending the space, we should first append the word and we should then append the space, right? So now what I can do is, for all the strings, so let us say this is the answer vector that we need to print. So for all the string I in p of n I dot pop underscore back and answer dot push underscore back this time, and then I can return the answer only. I think in this way I can keep track of all the strings that I have visited so far. What is int? Okay, okay, okay. So let us say this string is as str. Okay, I'm not getting any output. So now what is the problem? So let us try to see what the problem is. So this logic is all clear, but whenever I am saying all the strings, so this word will match to this string, and dp of I plus 1. So let us see out str all the possible solutions. We are not getting any output. Just let me check. We have a string s. Once we sort this, when we say that what is the so let me just see out all those possible which I'm making them. Yeah, so at least there is some output. So cat is getting matched. So now in the dp of what I can do is, okay, so I had to initialize it with an empty string. That's why I think there was no output coming. Now the output should be there. Yeah. So let us see if this passes the solution. Okay, so there is a time limit exceeded. Um, so if we look at our solution, then our solution is order of n to the power 4 almost. So let us see how many test cases are getting passed by now with this approach. Okay, so 31 test cases have been passed and 5 test cases are failing. So let us now read the questions more carefully. So yes, now I think our first optimization would be over here to use that unordered set, which will help us to find out. So basically what I am trying to say is, so we are iterating over all the positions in the given string, and then we are trying to iterate over all the possible choices in the second string, all the possible lengths. Or what we can do is, yes, I think we can do this. So what we can do is, let us say we are storing the strings in a vector, right? So we are storing all the strings in the vector, all the possible. So we are storing all the possible indices where we actually found out the vector. So the ending of the vector. So basically, suppose we are at the current string, we are at the ith position, right? And what we know that from past, we know that at which all indices the string got ended. We can store that. So let us say for any j which is less than I, and if there is a answer up to j. So what our DP is trying to do? So we are trying to find any substring which fits in this j to I bar, right? So I instead of looping for all the possible j's, what I can do is I can store at vj, store that positions of j wherein I found the solution, right? And then I can use that j's to find out if it is possible to find a solution for this I, and if this I satisfies the condition, then I can push that I into the vector of positions, right? So let us say we have a vector integers which denotes positions, and it is currently having 0 in it, right? Because we have at dp of 0 we have something in the bucket. So now when we are iterate, so let's say we do not iterate over all the possible word choices. Instead what we do is, right, yeah, so what we do for this particular index, I will start iterating for int j equal to 0, j less than, so for int us, simply like that, right? So I know that dp of this position has something for me, right? So if j is treated as the starting position, then if j is treated as a starting position and length should be I minus j. So if 0 is treated as a starting to, so yeah, I minus j plus 1. So if this is the string, right, and if in our given set, so let us, so we do not need this sorting, instead we need an unordered set of string st. So we have this st. So if we can find this substring in st, if st dot find, so if this is equal to, if this is not equal to st dot end, that means we have this position, right? So what we can do is we can say okay, a solution exists. So let us say we track the solutions as b all pos is 0. So what we will do is okay, the solution exists, possibility is 1, and also what we will do, so dp of I will now have this result, right? What is this result? So actually this is the same case as the previous one, because actually this is the same case as the previous one. Why? Because we are iterating over the vector of positions, and then if this substring satisfies this condition that okay, I am present, so what I can do is I can keep at this position, I can keep track of all the positions from which I am able to go, I am able to go to which all positions. I can keep track of that. Yes, and once I can keep track of that as to which all positions I can go from the current position, so I can then okay. So I think this is better. It has the same complexity. So let me try to do this. So everything in the DP of, so yeah. So what I need to do is for string k in DP of j, k plus, yes. So I think in this way, if it is for after coming out of the loop, if POS exists, then what we can do is POS dot push underscore back, and we will push PO, we will push I, right? Because yeah, because solution exists at this index as well. So now I think this is fairly simple and remains the same. So this is a bit so this is I have tried to optimize it a bit. So solution is not there. Yeah. So actually I need to push I plus one. Also there is some mistake. Okay. Yeah. So This should be I plus 1. Let us see if there is any improvement over the time complexity. We can try to further optimize it. Let's try this first. I think it is the same test case on which it is failing. Yes, the tune test case is passed, but this one failed again. So what now? We can try. I think this step we need to avoid somehow. How will we avoid this? So what we want is that this string bw should be present on each and every instance of POS. If we are able to find this, so let us say I think our approach is what is in stride of the string, right? Even if we consider our approach is order of n to the power 4 for now, but we need to do it in order of n cube to pass the solution. That's what my thought process is. If we are able to do this in order of n cube, then we would be done. So what I am thinking is if it is possible to move. So, so what I'm thinking is let us apply BFS separately and let us not do this over here, right? So what I will do is if it is possible to move over here, so I will just push DP of just do is DP of I dot push underscore back J, which means that I can reach to this position from this position, right? And also obviously POS will be one. Now let us say this is vector of int only. Right. Now once we are done with this, now we have to apply BFS because dp of n stores all the possible ways in which I can reach at the last position, right? All the possible indices from which I can reach the last position. So let us, so what I will do is I will create a string. I will create a string and then I will add a substring, and then from this position. So basically, yes, what I will do is, so let us apply a, let us queue of pair of string comma int. Let us say this is q. Now what we will do, um, q dot push. Let us say we are pushing an empty string and the index n. So while not of q dot empty, what we will do, so auto tp is, and then once we are done with this q dot once we are done with q dot, yeah. So this is the string and let's say the index is this. Now, now what we want for int nxt in dp of ind. So that means whatever is the nxt, what I need to do is string narrow is str nxt comma, and next thing is we also need to maintain, right. So let us say visit of, now string is nr, and what we need to do is, let us say we have this string mid, so mid and q dot push mid comma nr. Now at the top, if ind is equal to 0. Okay, so what is the, so if no, actually dp of ind is empty. So I think every index will be starting from 0. So yeah, if int is equal to 0, then we are done. So what we will do is, let us say we have this thing called vector of string answer. Yeah. So what I will do is read dot pop underscore back and answer dot, yeah, visit of actually there is no concept of visit, right? Because there won't be any multiple cases. I don't know why there is any error over here. Okay, this is also, we're not getting any output. Let's see what all strings are getting generated. First of all, it should be an empty string. It means over here something is not working properly. So we do not need dp of 0 because we have this position 0, and then if it's possible to get, then you will say okay, it is possible to reach to I from j. Then we need to find out from where it is possible to reach n. This means I can reach on the first place from the second place. It should be dp of I plus 1. Shit, yeah, the same mistake all the time. Gets so basically we need to reach up to n minus 1, I guess. And this should be equal to minus 1 in this case. Yeah, we can reverse the string. What we can do is, so let me think. So from next we can go up to the ind. So now I need to reach up to the next minus 1. So this information for next minus 1 is stored in the variable next, because see, for the index n minus 1 information was stored in n. So I think next minus 1 should come. And let us do this way. And before pushing, let's reverse. I want index equal to 0 only. Initially, IND is 10. Then we got a dog, right? So basically, we got dog because see. Let me just reiterate what. So I think this should hold plus 1 positions, right? They are holding. So basically, DP of I plus 1 stores that all those indexes from which you can reach up to the ith position. Yes. So if I want to query on I and D, DP of I and D, then it will store all the positions from which I can reach up to I and D minus 1, right? In the similar way, in the similar way, DP of next will hold all the possible ways in which I can reach from a particular point to next minus 1. So DP of 1 will hold all the possible ways in which I can move from starting index to 0. So for them, this index is 0, and then by what I am passing over here is 0 itself. Finally, we got something good to show, but let's see if it passes. I think this is order of, yeah. Yeah, so this solution is accepted and it is of complexity order of n cube. Why? Because over here we are using order of n cube approach, and down we are using BFS to generate the answer in order of n cube. Why? Because this is order of n square and then this while loop runs for order of n. So yeah, in total it is order of n cube. So it was a bit exhaustive solution. Is there any order of n square? Let me check if they are using DFS. So I want to find out what is. So let us try to find out the complexity over here. So this is order of n. This is order of n square because they are finding the sub str. Okay, so they are using recursion to calculate the answer. If I can somehow convince myself that even their solution is order of n cube, they are using the recursion. Okay, so I think our solution works. That's great. So I think we do not need any more for optimizations. If you have any other approach which is different from this, so basically what we did, we first calculated the parent and did a BFS to calculate all the given strings, right? So I think this is all for the video.